Good morning, sixth grade, and happy Monday. I'm excited to jump in with you guys and do our last day of new learning. And what I mean by that is this. This is going to be our last day of our area and surface area unit, which is our last unit of new learning. So that means that after this unit is over, we're going to jump into a review unit where we're going to go back through all of the content really fast and only hit the major, really important parts of sixth grade so that going into seventh grade for you will be a breeze because you'll have all of this stuff fresh in your mind. Some of you don't ever remember learning about rational numbers or dividing fractions. And that's just because it's been almost a year since you've been practicing those skills. And yeah, we've been doing learning farm homework, some of us. And if you have been, then you feel a little bit better about it. But if you haven't, this unit is going to be a really great refresher for you. So I'm really excited to see how it benefits you. All that to say, today is our last day to learn new things. And then the rest of the week, we're going to be preparing for our area and surface area test that will be on Friday. Those details will be released on Friday, so you won't be able to take your assessment early just because I don't want someone taking it on Thursday, sharing the answers with somebody else. So we're going to treat it like we would an assessment day, and that test will be released on Friday on the dot. So don't try to go and ask for it early. That being said, today is our last cool down for the unit. So I hope that you guys are excited. And I know that you got some preview learning on this topic of volume and surface area on Friday. You should have watched some Khan Academy videos and done some practice problems to prepare your mind for the concept of volume. And the reason why we're ending here is because a common misconception is that volume is the same as surface area. And I saw this a lot in your cooldowns. A lot of people, when they were given their surface area problem for their rectangular prism, were multiplying length times width times height. And I responded really quickly to you and let you know you are finding volume by doing that. You're not finding the surface area or the way around a figure. So that being said, I'm going to kind of go through some of those things and then show you our final thought at the end. You have a warm-up practice problem, exercise set, and a cool down for today. And so I'm excited for you guys to get to jump in. So this was another example I thought of that would be really helpful for you. So surface area versus volume, right? So many of you have seen a Rubik's Cube before. This picture is of a Rubik's Cube that has been completed. So each side is all the same color. This side is yellow, red, blue. On some other sides, you might see green, orange, white. So the Rubik's Cube is made up of equal sides, right? Every side is the same because it's a square. And each side is going to be a different color when the puzzle's been solved. So if I wanted to find the volume of this shape, I would multiply 3, right, its length, and 3, its width, and 3, its height. So I would multiply length times width times height, and those dimensions, 3 times 3 times 3, would be 27. Because 3 times 3 is 9, times 3 more is 27. That's great. That would be the interior of my shape, or how many total of these squares you see, right? So I see 1 square, 2 squares, 3 squares, 4 squares, 5 squares, 6 squares, 7 squares, 8 squares, 9 squares. There are 9 squares on one level, which means there's 9 more squares on this second level, and 9 more squares on this third level. So if I have 9 times 3 is 27. The volume is how many layers of blocks you see. Or if you wanted to think of it, you could think of it, if I were to fill up this container, this Rubik's Cube, with blocks and form it with blocks myself by putting them all together, I would form it with 27 little blocks. However, surface area is thinking of the area of each side, or the surface of each part, right, the entire surface of the shape, by finding out how many squares is the area of each side and then adding them up. So for instance, because this is a square and every side is the same, this red side I can count has 1, 2, 3, 4, 5, 6, 7, 8, 9. It has an area of 9, 3 by 3. So there's 9 squares that make up this face or this side of the shape, which means that there would be 9 squares to make yellow, 9 squares to make blue. And then on the other side of this shape, right, I have where there is a top, there is also a hidden bottom. Where there is a left, there is also a hidden right. And where there is a front of blue, there's got to be a back of green. So every one of these sides has a side on the other side of the shape that's hidden. So there are 6 sides to my figure, right? Top, bottom, left, right, front, back. So for a cube, I have 6 sides. So if there are 9 squares for each side and there are 6 sides, that means that there must be 54 flat squares that I would need to cover this Rubik's Cube. And if you've ever used a Rubik's Cube before, or you're old school like me, then you may have seen the original Rubik's Cubes, you have your own stickers, right? And so you could even peel these stickers off, right? And if I were to count how many stickers there are on this Rubik's Cube, there would need a total of 54 stickers to cover the outside of the Rubik's Cube, okay? So that being said, another way that some of you have thought of volume is using your thoughts in science, right? Volume is filling up a shape. The volume of a cylinder or the volume of a rectangular prism in this situation is like filling up a plastic container with water and thinking about how much is inside it. Just like this Rubik's Cube was filling it up with tiny blocks, right, would tell me the volume of the shape. You could also think of it filling with water, okay? So if you were given a science problem like this, you know that you're thinking of volume, and you would be thinking length times width times height to find out the entire amount of water you would need to fill this shape, okay? Surface area is different because it's not the inside, it's covering the outside of the shape. So if this was a fish tank and you were going to give it to somebody as a present, you would need to wrap this fish tank in wrapping paper, covering all the 4 outside sides as well as the top and bottom. That is surface area. How much water you put in the fish tank is volume. So that will just be some good distinctions for you guys as you look to the next couple problems. So because we're going to look at volume more, I want to revisit the formula. You should have already seen this as we talked earlier, but officially volume is multiplying your width times your length times your height. So if I have this shape here and my width is 4, length is 12, height is 3, then I'm multiplying 4 times 12 times 3, which would give me 48 times 3, which is 144. So I would fill this shape with 144 whatevers I'm multiplying by. Now, today we're going to be looking at some activities that involve a perfect cube. And what I mean by that is every side of the cube, kind of like my Rubik's Cube, is the same. So a cube, as you know, is not a rectangular prism because it's like the equivalent, the 3-dimensional equivalent of a square. So each side in this picture is 5. I have 5, 5, and 5. So that means this side of my shape is a 5 by 5. This side of my shape is a 5 by 5. This side is a 5 by 5, etc. So every side is made up of a square, and we just put all those exact identical squares together to form a cube. Okay? If I wanted to find the volume of a perfect cube, I could just use the formula that I saw here, length, width, height. Well, the length is 5, the width is 5, the height is 5. So that would be like multiplying 5 times 5 times 5, which gets me 125. Now, you see here on the side, and this is the key component, it is written like an exponent. Why? I want you to think back to our expressions and equations unit where we discovered exponents in more detail. How is this equation equivalent to this equation? They both equal 125. Good. So if you thought for a second, maybe you paused the video, maybe you drew it out. 5 to the third power, right? 5 cubed, here we go, right? Here's a cube. This is why that language is the way it is. 5 cubed, not 5 squared, 5 cubed is like telling somebody, I have 3 5s and I'm multiplying them by themselves. I have 5 times 5 times 5. It is not 5 times 3, that's 15, right? It is 5 times 5, which is 25, times 5 again is 125, okay? So when we have a perfect cube, we can represent this length times width times height with an exponent of 3 because every side is identical, and I know that I'm multiplying 5 by itself 3 times for the length, the width, and the height. 5, 5, 5.